Hi, this is Jack at Jack's Transmissions. Ever install a selector valve body and find you're getting shift fork errors out of nowhere and it's just not working no matter what you do with it? Well, in mid-2015, Nissan made a change to the selector valve body where they won't work on an early car. So if you take a mid-2015 or later valve body, put it in your like 13 dBA like this one, or anything that's made before 2015, it's not going to work. It's actually going to look just like this video here, which is this car with a 2016 valve body in it. You'll see that the line pressure is going to go up and then down, up and then down. You're going to hear clicking from the transmission repeatedly as it's trying to force itself to pre-select second gear when you put it into drive. After a while, it's going to time out, limp out, and give you an error message with this code. Check it out. My car is a 2013 and this is a 2016 valve body. So, initial startup, it passes its self-check, everything looks normal. We now go into drive and watch the line pressure right here. I was trying to engage, but it cannot because it's out of phase. It's just going to keep attempting to go into gear unsuccessfully until it finally errors out. There it goes. So as you can see in that video, it looks like there's a valve body problem, right? Like you have a bad solenoid, you're getting a shift fork C code, maybe there's a problem with the shift fork or the synchro or something. It's not. Everything's fine. It's just the sensors in the valve body are out of phase. And I'm going to show you, I made like a little tool to check these sensors to be able to differentiate from a late valve body with an early, and to fix a late valve body to work into your early car is actually pretty easy. You just have to replace some sensors. So before I go into details about how to do this, I need to make a public service announcement to you guys that are do-it-yourselfers that get a hold of these valve bodies. I know the urge is strong. I know you guys really want to take these things apart, but don't. I know there's a guy on the internet that'll tell you that there are filters in this valve body and that every little issue you have with the GR6 will be fixed by cleaning those filters. That will not happen. In fact, you're going to take it apart, find the filters already clean, clean them anyway, put it back together, and it's never going to work right again. You just broke it. Leave it alone. Avoid the urge of opening this valve body and tearing it apart and cleaning it. Cleaning a valve body doesn't do anything unless you had a catastrophic failure. If the valve body was in a transmission that had a broken gear, a broken retaining clip, something where metal got all over everything, got into every little orifice inside the trans, then you need to take it apart and do that. But that's my job. If you need the valve body rebuilt completely, send it to me. There's another guy on the internet that has you do clicker tests on the solenoids. Every week, multiple times a week, I get emails and calls from people that want to order solenoids from this valve body. I'll then ask them, those solenoids never go bad, why do you need a replacement solenoid? And they'll tell me it failed the clicker test. I'll tell them, that test is not valid, your solenoid's fine, leave it alone. They order it anyway. They get the solenoid, they check them, and then they scream at me that they don't work in their clicker test. I sold them brand new Borg-Warner solenoids that were bad. It is really annoying. It's incredibly frustrating. You guys need to stop. If the valve body came out of a trans, it did not have a catastrophic failure, the solenoids are fine, the filters are fine, leave it alone. By taking it apart, you are compounding the issues you're having with the unit, and you're never going to figure it out. It's going to be a mess. So let's take a closer look at these valve bodies and see what the differences are. Okay, so we have both valve bodies in front of us here. This is a late valve body, and this is an early. So what I did is I made a simple tester here. It's just a voltmeter that we see here on the display, and then it has a 5-volt power line that would connect to the sensor. So I'll plug this in. I'm waking the sensor up now. So this is just basic, automotive 101 5-volt lines here, for sensors. So you have a 5-volt positive, you have a ground, and then you have a 0 to 5-volt signal output. This is reading the 0 to 5-volt signal output. And this sensor senses the magnetic field on this piston. There's a magnet inside the piston. So when the magnetic field is stronger, the voltage goes down. When it becomes weaker, it goes up. So knowing this, you would think that it's linear. So the further we go away, the voltage change is going to be the same for every, let's say, millimeter of distance. That is not correct. There's actually a curve to this, which makes it more complicated. So the piston is going to move more distance for the voltage change on this side than it would when it's further away. So since this is the second gear side, let's run a little test here and see what the difference is and why this unit is getting so aggravated with the 2-4 fork. We're going to take our tester and plug it into the early valve body, which will wake up our 2-4 sensor here on the early valve body. And we're going to move the piston all the way over till it bottoms out in the housing, like it's engaged in second gear. So we're reading a 1.16 voltage here, 1.16. So remember that is its furthest distance traveled right here is 1.16 in the second gear direction. We'll go over here to our late valve body and do the same thing. We're going to go all the way over, bottom it out into the housing, and this one we're getting 1.07. So we have basically a 0.1 volt difference between this valve body and this valve body. Let's do a little experiment here and move this piston over until we get to 1.17 like we did on the early valve body. That's pretty close right there. Look at how much the piston has moved here. I've actually measured this, and the distance that it's moved compared to this one over here is 2 3/4 millimeters. So this piston, with the voltage that it's reading off of the sensor, is sitting almost 3 millimeters more in this direction than the early valve body. So we're out of phase almost 3 millimeters over here. So now, what does this mean? Well, when we put the car in gear, it's selecting first gear, of course, but it's pre-selecting second. It's getting second ready to go because that's how DCTs operate. So when we see the line pressure spike up and then go down, and then up again and go down, what's happening is we're in neutral. When it spikes up, it's shifting into second. It's trying to engage second. But it's not seeing the voltage it expects. The voltage is different. So it pulls it out of gear and then tries again. Pulls it out of gear and tries again. And it does that repeatedly. That's why you see the line spike, and that's why you hear the clicking over and over again. Click, 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 because it goes back and forth, and it continues to not see the voltage it expects. It eventually times out, limps, and gives you the 244 code. Well, why isn't it giving us a distance code or a sensor code or something? The reason it's giving us a 244 code is because there's no code for this issue. The TCM doesn't know how to communicate it's having this problem. So it gives you a generic 244 code instead. So, knowing this, what can we do to remedy this situation? Well, you're probably thinking, okay, maybe there's a difference in the casting or the piston magnet location that's causing it to be out of phase like this. Unfortunately, that's not it. The issue is with the sensor itself. The sensor is actually reading out of phase. Everything else mechanically is exactly the same between these two valve bodies. The sensor itself is the problem. So if you want to convert this 2016 valve body to work in my 2013 DBA, all you have to do is remove all of these position sensors. They're all in the same harness here with this connector. Very easy to do. Unbolt everything, pull them out, grab the same sensors from your early valve body, transfer it to the late, and you just converted this late valve body to work in an early vehicle. That's it. That's simple. So if you have these symptoms and you have this code and you just put in either a new valve body or a new trans in your early car, this is probably what it is. Now, what about the other way around? What if you want to take an early valve body and put it into a late car, like a 2016 car? Well, because everything's going to be out of phase in the other direction, and the distance traveled gives you a lower voltage change, it will actually work the other direction. However, it will not work properly. You'll drive the car around the block, everything will feel fine, but randomly, every once in a while, maybe like a week later, you'll get a random fork code, or the clutch engagement will be weird, or the gear selection will be slow. Something will be goofy going on with it that just doesn't seem right. The car is just never right. If that's the case, perform this test. If you have an early valve body, it's the same thing. Just take the late sensors, put it on the early, and then it'll work on your 2016 or later car. That's it. That's simple. So there you go. I hope this helps you out. I hope you didn't already pull all your solenoids out, pull the valve body apart and ruin it, and make this a more complex issue. It's really this simple. All right, well, there you go. It seems pretty easy now, doesn't it? But, a lot of people don't know this, and we figured it out. We carry a lot of these parts in stock. If you want to, transfer a 2016 valve body into like an early style, I probably have sensors I can swap with you. If you need parts for your valve bodies or any other part of your transmission while you have it apart, give us a business. We're sharing this information with you. We're helping you. We're helping to do it yourselfer. If you buy from somebody else or use our information and use somebody else's parts, then what's the point of doing this? We do this to make money. We're a business. So I'm hoping this helps you. I'm hoping that the help is reciprocated and you've given us your business and your trust. And yeah, I guess that's about it. Thanks for watching.